Hello students, and welcome to our unit on linear functions. So to start off, let's just do a bit of review. When we're talking about slope, rate of change, and common difference, we're all talking about the exact same thing. They're synonyms for one another. So we can use each one of these terms here interchangeably. Now, we also have two familiar formulas, delta y over delta x and rise over run. Remember that delta is just the scientific notation for change. So this is really change in your dependent variable, or your y variable, divided by change in your independent variable, or your x variable. So we can determine slope using more than just these two formulas, and that's what we're going to be taking a look at in these series of videos. So we can determine the slope of a linear function from any 2 points on the line. So given any 2 points that satisfy a given linear function, we can always find out what the slope is. And more than that, later on, we're going to be able to, from any 2 points on the line, derive what the equation for the entire line is. So we can also determine the slope from the slope-intercept form of a linear equation. That's just by inspecting the equation itself. Without doing any calculations, we can directly find out what the slope is. And we can determine the slope indirectly by knowing the slope of parallel and perpendicular lines. So why is the slope important? Well, by knowing the slope, we can do the following. With both the slope and a single point on a linear function, we can quickly create an accurate graph. And more than that, we can actually come up with what the entire equation of the function is. So by knowing the slope and one of the rise or the run of the function, we can find the other. So if I tell you what the slope is and I tell you what the rise is, you can find the run. And if you know the slope and the run, you can find the rise. And lastly, from the slope of a linear function, we can determine equations for linear functions that are either parallel or perpendicular to it. So one of the first things we're going to take a look at is a bit of review. So we're determining slope simply from a graph. So an important thing to remember here is we're going to be using the rise over run method. So slope is equal to the rise of a graph divided by the run of a graph. So in order to help us find the rise and run, we first need to identify integral points on each line. So remember, those are points which have integer values. So I'm going to get my big marker out here, and I'm going to put some dots at our integral points. Okay. So, and let's grab my red marker. So here, 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 and we'll grab a green marker. Oh, it's a little darker, but that's okay. Here, 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 let's say. Okay, so these are all integral points, parts where our line crosses at exactly integer values. So your x value and your y value are both integers. So from this, what we want to do is we want to determine the slope of each one of these lines. So let's take a look here at the slope of our red line. Just going to grab a thicker pen here. So from this point here, I need to have what is my change in y. So that's my change vertically. So to go between points, I have to go up 2, and that's positive because up is positive on the y-axis, and right 1. And that's also a positive 1 because right, the direction right, is positive on the x-axis. So I go up positive 2, and I go right a positive 1. So slope in this case is going to be 2 over 1. Okay? And we can see that that's consistent no matter what points I'm going between. So let's say I'm going between this point here and this point here. So I go up a total of 1, 2, 3, 4. So I've got my changes 4 vertically. And now, what about horizontally? I go right 2, 1, 2. So, and we see that these two quotients both give us a value of 2. So the slope of our red line is exactly 2. So I want you to try pausing the video here and finding out what the slope of the blue and green line are. Okay, so let's find out using the exact same method. First we'll do blue, and then we'll do green. So let's take a look. So if I'm going from any point on this blue one to another integral point, the nice thing is it doesn't matter which direction you go. You can go between any 2 points in any direction. It's completely up to you. So let's do a few different examples here. I'm going to start at this point here, and then I'm going to go to this farther point. Okay, so it doesn't matter which direction I choose or which 2 points. So here, what's my vertical change I need to move from here to here? Well, my vertical change I need to move down 1, 2, 3. So down 3 is a negative motion on the y-axis, so I'm going to get a change of -3 there. Okay, so I've moved down 3. 1, 2, 3. So now I need to find out what's my change horizontally. So I move 1, 2, 3, 4, 5, 6 to the right, and moving to the right is positive, so this is -3/6. So let's show that going between another 2 points in a different direction gives us the exact same values. So what if I move from this point here to this point here? Okay, so first I do my vertical change. So I'm going to rise of 1. So I get 1 over. And now let's see what our horizontal change is. Here I have to move to the left. So remember, left on your x-axis is negative. I move 2. So I get a value of -2. And notice that both of these simplify to a fractional value of -1/2. And you'll be guaranteed to get the exact same consistent slope providing your methods are correct. And it does not matter which points you choose or the direction you choose to go between them. Okay? It's always what's your change in your vertical axis, and then what's the change in your horizontal axis. And kind of the layman's way of saying that is simply what's the change in your rise, what's the change in your run. So let's do the same for green here. So for our green guy, whoops, sorry, pulled up the wrong one. For our green guy, I'm going to go between the farthest 2 points first, and let's go from this one to this one. So first I need my vertical change. So I'm going to go 1, 2, 3, 4, 5. So I have a rise of 5. So now I need to find my horizontal change. So I went 1, 2, 3, 4, 5. Now my horizontal change. And notice I'm moving to the left, so it'll be negative. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I get 5 over -10. So now we're going to show that I'm going to choose another set of points, and we're going to see that we're going to get the exact same slope. So let's choose, for instance, like this point here to this point here. So first I do my vertical change. I have to go down 2, 1, 2. So I have a change of -2 on the y-axis. So I go down 2, and then I'm going to go right, 1, 2, 3, 4. So right on the x-axis is positive. And notice that both of these quotients both simplify to give -1/2. So we're going to take a look here at an important idea. I'm going to come back to this graph in just a little bit. One of the first things we want to do is notice here that your red function is a positive function, and then these two slopes, not only are they equal, but they're both negative. So we can generalize a specific pattern here. So what you can do is when you hold up your arms in front of you, so let's say these are your hands and your arms, you're making a house, kind of like a kid's drawing of a house. So this is the roof. So your left arm always looks like a positive slope, and your right arm looks like a negative slope. So take a look here. This direction is the general direction of a positive slope, and notice that it matches our red positive slope. This is the general direction of a negative slope, and it matches the general direction here of our negative slopes. So what we're going to take a look at as well is simply by inspection, how can you tell if a slope is positive or negative? So let's take a look here. We want to determine simply what the sign of these two slopes are. Which one is positive and which one is negative? So it can't really show me holding up my hands or my arms, so I'm just going to redraw our little guy here. So this is always a positive slope, positive increase. Oh, sorry, that did not turn out well. Let's try that again. There we go. and this is always a negative slope or a negative rate of change. So take a moment here and think about which one of these is positive, which one is negative. So it shouldn't take too much, and we can see that the general shape of a positive graph matches our green. So in this case here, what I'm going to say is for our green guy, this slope is a positive slope. So now, what about for our red guy? Well, if we take a look, this general slope is a lot like this general slope, and it's definitely not like this one. So the slope it's closest to is this guy. So what we're going to have is, this is a negative slope. And once our eyes are trained, we can do this really, really quickly, but also effectively.